Yeah, this is Anshuman. I'm a sixth form chemistry teacher, and um, best wishes to everybody who's giving their A level paper through, that is tomorrow, right? I based upon the analysis of the paper number one and paper number two, what appeared, right? This is not a prediction by any means, but just a suggestions. You all complete your revisions, and after that you can go through these just as a revision purpose, right? So what are the important portions you can revise after you complete your total revision, right? The first portion of the physical chemistry is that the rate of the reaction, right? In this rate equations, right, we're seeing that the order of the reaction questions, right, will be tested, right? And most importantly, the rate experiments, which all are there, right? Such as the disappearing cross with the sodium thiosulfate and HCl, right? Gives you NaCl plus SO2 plus sulfur dioxide plus sulfur, right? That's fine precipitate forms, right? This can be a cross, that cross reaction which is there, right? Of visualizing the cross. Or it can be also connected with the spectrophotometer, right? Iodine clock reaction will be there. Yeah, metal plus acid gives you salt and hydrogen, right? And we are getting that hydrogen gas in the in the gas syringe, right? And we are trying to note down the amount of the volume which is coming and plotting the concentration and time, right? Next is thermodynamics, right? In the thermodynamics, what I analyzed in the paper number one, paper two, that Born-Haber cycle was not tested that much, right? So yes, Born-Haber cycle is a very important bit we have to see into, right? Enthalpy of solution, right? Enthalpy of solution where Hess's law application is there, right? That enthalpy of solution connected with enthalpy of hydration with lattice enthalpy, right? That if you're having a much smaller ion, right, the enthalpy of hydration is more exothermic. If you're having a larger ion, right, the positive charge ion density will be lower, right? And hence enthalpy of hydration will be less exothermic and so on, right? Connected with this equilibrium constant calculations, Kp Kc, right? This will be also linking up with organic chemistry, right? The esterification, right? The alcohol, right? Alcohol plus the carboxylic acid, right? Gives you ester, right? Give you ester plus H2, right? A condensation reaction, yes. So ice method will be also connected with this, right? To find out. Next, we are moving to the energetics part. In the energetics part, calorimetry, right? All the calorimetry questions, right? The four calorimetric questions you have to go through is what? The salt when it's added to water, right? And you're taking in a polystyrene cup and measuring with the thermometer, right? First we're measuring Q is equal to MC delta T, then MC delta T, this whole will be coming in joules, you divide by 1000, you get kilojoules, right? And then you divide the Q in kilojoules by the number of moles of the substance or the salt volume. This is the first type of the calorimetric question. Second part is that acid base neutralization reaction, right? It's exothermic, we know always, but yes, for the number of moles over here, you have to take the limiting reactant. That bit you have to understand. Third is the displacement reactions, which are there calorimetry, right? Suppose a zinc plus copper sulfate gives you zinc sulfate plus copper, right? And yes, there's a graph which is being plotted, right? The graph which is being plotted, and you have to extrapolate the graph, that bit, right? And yes, here also, once you find Q is equal to MC delta T, you have to divide by the limiting reactant. You have to calculate the limiting reactant, that also bit, right? Now, this energetics will be linked up with what? The lattice enthalpy, right? What is this lattice enthalpy? Lattice enthalpy is the enthalpy change to break down 1 mole of an ionic solid into its gaseous ions, right? And obviously that lattice enthalpy depends upon the size of the ion, right? If the size of the ion is smaller, the lattice enthalpy is larger. If the if the charge of the ion is more, the lattice enthalpy will be more. Moles will be tested, right? In MCQ especially, right? Now, linking to moles, you should be very well aware of how to find out the water of crystallization, those questions, especially then moving on to the part of LR, back titration also, and acid base titration. Yes, this amount of substance you also will be tested by the making of a standard solution. What's a standard solution? A standard solution is a solution which is of known concentration, right? So we take the salt, we take it in a measuring boat, right? Weighing boat, put it onto a weighing machine, and add it to a, a particular volumetric flask, right? Right, volumetric flask we take because to eliminate the errors, random errors which is coming, right? Now, moving on to the part of the organic chemistry. In the organic chemistry, the aldehydes ketones were not tested that much in the paper one, paper number two, right? So yes, was tested, but not that much. What I feel, these are not my predictions. Again, I'm saying after you revise, you can go through all these again. Aldehydes and ketones, nucleophilic addition reaction they undergo, right? We know that. Chemical testing of the aldehydes and the ketone, we know that aldehydes will undergo oxidation, right? Will undergo oxidation to a carboxylic acid. Ketones does not, because they don't have any leaving hydrogen, right? And yes, so you if you add an oxidizing agent, such as what are the oxidizing agent we having? Copper 2 plus ions, right? That's a blue color turning to what? Turning to the turning to orangish color, right? Ag plus ions, right? You're having, and it turns to Ag, the silver mirror test. And finally, potassium dichromate changes from orange to green, right? This only changes color in aldehydes, right? Because aldehydes will be accepting to undergo oxidation, right? Which ketones won't. Yeah, chemical testing part. Yeah, and reduction. So we know that we can reduce ketones to secondary alcohol. We know this, right? By using sodium borohydride, right? Sodium borohydride. Or we can also reduce aldehydes, right? To what? To a primary alcohol, right? Using sodium borohydride. These all are having the hydride nucleophile. This is very important, right? H minus nucleophile, right? This is also a nucleophilic reaction we are having, a nucleophilic addition reaction. Now moving on to the proportion of the amines. This was not also properly tested. What I suggest that it might be a important portion to look around, right? That amines are bases, right? Amines are bases, and obviously, if you have got a primary amine, secondary amine, tertiary amine, a tertiary amine will be having more basicity, right? Because the lone pair of the electron for this is a secondary amine, right? This is a primary amine, my bad, right? This is a secondary amine, right? And this is a tertiary amine we are having, right? So we know that if you're having an alkyl group that has got a positive inductive effect, right, it'll be pushing the electrons towards the nitrogen, and this lone pair of the electron will be easily available, right? We apply the Lewis base theory, that Lewis bases are those which will be donating the lone pair of electron. So most inductive effect will be here, and we'll be having that basicity part, right? And deeper into that nucleophilic substitution reaction which undergoes nomenclature and the isomerism for entire organic chemistry. That's right. Now halogenoalkanes, we know that halogenoalkanes undergo nucleophilic substitution reaction. There are some tricks we have to know, that if you add NaOH, right, in presence of aqueous solution, right, NaOH aqueous solution, it gives rise to a substitution reaction. But the same NaOH, if you take in the alcoholic medium, right, it undergoes elimination reaction, right? In the elimination reaction, also go to the part that if you take a if you have a if you have a chlorine, right, if you have a chlorine in the second position of the carbon, right, that gives rise to what? That gives rise to stereoisomers also, right? E and the Z isomer, right? Yeah, chromatography. uh Chromatography will be tested, right? Chromatography might be tested, right? Again, I'm saying that these are not my predictions. These are the things which you have to do after you complete the revisions on your own, going to the past papers and all, right? So next is what? The chromatography will be tested, linking with the amino acids. Yeah, TLC, right? The thin layer chromatography with the RF value. GC chromatography, gas chromatography, right? Gas chromatography, we know that the retention the value, the graph, from the graph we can identify the particular substance, right? And yes, gas chromatography is also linked up with the IR machine, right? Where we can see the IR graph, right? About that 800 1800 degrees, sorry, 1800, if the IR strong sharp band comes, right, it is a C double bond O. If you're having a broad a strong broad band around 3000, right, it will be the OH group in a carboxylic acid. If you get the strong broad band around 3300, is OH group in alcohol and phenol, and these bit, right? Yeah, mass spectroscopy, you will be finding three kinds of question. One is the fragmentation, one is the molecular weight determination. um, Second is the isotopes, right? The isotopes graph, right? The percentage abundance. And finally, for the AQO people, right, you'll be having the TOF, right? Time of flight. Now, finally, about the carboxylic acid and the derivatives, the testing, chemical testings, yeah, esters and the ester hydrolysis, right? This linking with the KC and the ice method is also on the cards. Now, inorganic chemistry. In the inorganic chemistry, what I saw that the paper number one, paper number two, not much about the period three elements and the oxides has been tested, right? So short questions might be there out of it, right? um, for the inorganic chemistry, you have to have a solid idea about the identification of cations, right? The identification cations by the NaOH test, right? In the NaOH test, that it can give you two precipitates, right? White precipitate. It can be giving a colored precipitate, right? If it gives a colored precipitate, it's a blue precipitate, then it's copper 2 plus ions with NaOH. If it gives you a light green color, right? It is Fe2 plus, right? And if it gives you a brownish color precipitate, it's Fe plus 3. A white precipitate, we know that if there is aluminum ion, right, it will be dissolving in excess NaOH. And in excess NaOH, Mg2 plus and calcium won't dissolve, right? Those parts. Anion testing, such as the chlorides. This is a very important part. I'll be uploading a few more videos by today night. So do subscribe my channel so that you get an email alert, right? You'll be getting an email alert about when I upload the video. You can go to, again, I'm telling you, these are not my predictions. These are my experience as more than 25 years of experience as a sixth form chemistry teacher, right? So that's really helping you, right? Chloride testing, or it can be if you have got a chloride, it will be having with the AgNO3, you get like a white precipitate. A bromide is a creamish precipitate, right, of AgBr. And if it is a yellowish precipitate of AgI, that's a yellowish precipitate and all, right? Yes. The metal testing, which I of the period three mainly, you have to focus, right? Carry out simple test tube reactions to identify the transition metals and the aqueous solution. Now, required practicals. This bit you have to go through. I'll be uploading some videos also, about short videos. So do subscribe my channel, right? So that email alert can be there. You will be getting an email alert that, hey, Mr. Anshuman had sent an email alert, right? Uploaded a video. Yes, this bit is very important, right? As I've discussed in the earlier part also, making up a volumetric solution, right? Standard solution, right? Carry out a simple acid base reaction. Enthalpy change, I told you, right? The all the four kind of enthalpy change which are there. Investigation about the rate of the reaction is very important, very important, right? With temperature, with concentration, with surface area, um uh, uh, with catalyst also, right? Catalyst MnO2 might be tested for H2O2 reactions. um s- Carrying out simple test tube reactions to identify cations and anions, right? Distillation of a product from a reaction, right? This bit is also important, right? Yeah, test of alcohols, as I've linked this part also. The testing of a alcohol, right? Means if it is a primary alcohol, secondary alcohol, tertiary alcohol. Primary alcohol, secondary alcohol will be undergoing potassium dichromate, color from orange to green. It oxidizes, right? Primary alcohol oxidizes to aldehyde, then a carboxylic acid. Secondary alcohol goes to a ketone. That's solid, does not undergo further oxidation. Tertiary alcohol does not, because it does not have a living hydrogen, right? So potassium dichromate orange color won't change. A test for aldehyde, right, we can do by the Felling solution, Tollens reagent, as I've discussed in just a bit moment back, right? Test of alkenes, right? Bromine decolorizes, right? Orange. A carboxylic acid, right? That you can add calcium carbonate, right? Because it's a weak acid, right? Quite a weak acid, right? We will be having the carbon dioxide emission, which is there. Measuring the rate of the reaction is my favorite, right? This will be tested by initial rate method, right? Isn't it? By continuous monitoring method. EMF, this is very important, right? The electrochemical cell, go over it. Electrochemical cells with temp with the current change, right? The voltage with the ions, right? You are going from sodium ions to aluminum ions, right? A magnesium ion to aluminum ion. We know that as we increase the ion charge, the current will be inversely proportional, right? Isn't it? So this bit is very important, that the voltage will be directly proportional to the current and the time, right? So those graphs will be there. So those graphs is a very important important portion. A pH changes when a weak acid reacts with a strong base. So this is very important, that you will get a buffer region, right? You get a buffer region. So you have to also calculate the Ka of the weak acid, right? By the half neutralization point, we calculate it, right? I hope that you know it. Otherwise, you can go to my videos, right, in my YouTube channel, and you can search it there. Yes. So weak acid, strong base, you'll be getting what? The pH at neutralization will be basic, right? Isn't it? It will be greater than 7. Strong acid and a weak base, strong acid and weak base will be having a neutralization point of pH less than 7, and the solution will be basic. Here also we expect that the pH curves, right? That also you should go over the 4 pH curves. A preparation of a pure organic solid and test its purity, right? We can test the purity by the by the TL tube, right? By the heating apparatus we're having. Yes. We can also go for the extraction of the crystals by recrystallization, or by the low pressure extraction of the filtration, right? Those bit you can go over. Carry out a simple test for the identification of the transition metals and in the aqueous solution. Yes. Yeah, this is very important. Separation of the species by thin layer chromatography. This bit is a very important. Thin layer chromatography or gas chromatography. These are very important, right? So, guys, just one a simple thing. These are not predictions. When you cover all the portions, right? You cover all the portions. You can go through all these again, right? Just at the end. These are not prediction. This is for what I see that it might. You never know, right? These might come, this might, but what, based upon the paper 1, paper 2 observation analysis I've done, right, hardcore analysis, right, I suppose that these will be tested, right? Thank you so much. So this is Anshuman. I'm just I'll be adding more videos, short videos, today in between my work, right? And do subscribe my channel. That will be really helpful. Thank you so much. Thank you so much. Thank you. Thank you so much. Thank you. Thank you. And best of luck for your exams, right? Best of luck. Thank you.